Upon further inspection, a mechanical integrity podcast goes beyond the data and dives into the people, challenges, and stories behind reliability and inspection. Whether you're in the field or in the office, this podcast is for you because mechanical integrity isn't about assets, it's about the people who keep them running. All right, Bobby. Well, thanks for joining us today. You've been a lot of different places. I've gotten to know you here a little bit this year. What is your actual role these days right now?
Well, that's a good question. I have been a lot of places. My actual role right now is kind of a business strategist, coach, mentor. My passion is taking what I've learned at a refinery and then growing that into this will be my fifth engineering consulting company now that I'm working with.
5 consulting companies. So probably the opportunity to work with a lot of different people, a lot of different perspectives. So you told me a story a long time ago about coming out of college. So where did we start? Where was college at?
Yeah, well, I grew up in Arkansas. My dad was a plant manager for Whirlpool. And in school, I was good in math. I thought I wanted to be an architect until I realized that it took them 10 years after they got out of school and they didn't make a lot of money unless they owned a company. So I went into engineering. In the high school years, my dad was plant manager at Whirlpool, Fort Smith. They had 5,000 people, assembly line, building refrigerators, freezers for Whirlpool and Sears. So I worked on the assembly line 2 summers, made really good money, and decided a couple things. Number one, I never wanted to work on an assembly line ever again in my entire life. And I really feel and have a lot of appreciation for people that have to do that or do that. And number two, I realized I also worked for a bricklayer. I like working outside. I didn't want to be in a factory or an inside position. So when I got out of school or as I was interviewing, it was a really good time in the industry back in the late 70s. Golly, I say that, late 70s. But it's true. I had 6 job offers. I ended up taking one from an old refinery in South Arkansas, a company called Tosco. And I'd never been in a refinery before, but when I went and had the interview, and it just seemed like a interesting place to go and work. And I didn't know it at the time. I was there for almost 6 years, but that set the foundation for the rest of my life and career in terms of the equipment I work with and the people, learning how to work with different people from operators all the way through vice presidents.
So in the refinery, what did you do? How many hats did you wear? And looking back, what's the experience that you got working in the refinery that just became so useful, became golden for you later?
Yeah, I started as a project engineer. At that point in time, the industry was in a really good position. Margins were good. We were spending money on projects and special projects. So I worked on 3, 4 different projects. Probably the biggest one was putting a waste heat boiler on a cat cracker. And Greg, to your point, I didn't appreciate it at the time, but it set the foundation for everything. I already mentioned, learning how to work with others, from people, operators, again, all the way through plant managers and vice presidents. But it was working with the operators and the maintenance people. I was in projects, special projects, and then we had a downturn in the industry, and I went to maintenance. And I worked in maintenance for 3 years, planning, and I picked up emergency work orders from operations every morning at 5:30. I met with the night superintendent and the day superintendent to plan the work for the refinery. So I learned about all the equipment. I learned about how our industry thinks, how maintenance and operations, while it should be a symbiotic relationship, a lot of times they fuss against each other, not always help each other. But it really set the foundation for everything, that I did. Yeah. We had, as I was thinking about some of the questions, there were some incidents. Certainly, I was part of the fire team there. I helped put out a fire in December of '83 on the cat cracker. And that was very exciting and scary at the same time. I was there. We had a tornado come over the refinery. I was at the refinery when that happened. We were pulling blinds in a turnaround, an alky turnaround, and I was standing on a platform with 4 pipe fitters. And we had 2 blinds left to pull to start the unit back up. And I just walked down into the control room, literally, and they got gas with a wet H2S, and we had to do CPR on all 4 of them. So I was lucky that I wasn't one of the 4 that had to be, resuscitated. That was successful. But anyway, Greg, it was a place I loved being, honestly. But we had a downturn in the industry. We laid off 30% of the workforce. And then I just didn't want to be in maintenance the rest of my life.
Gotcha.
You've mentioned here a couple times that you've known Greg, or Greg knows a little bit about you. Let's get up into like the 1980s or so. How did you and Greg end up meeting?
Well, yeah, when I was at the refinery, there was a company using some advanced technology, inspection technology, acoustic emission, and automated ultrasonics. They came to the refinery and did a couple of demonstrations. And that was about the time that the things at the plant were causing me to question where I was at and why. So I was looking to leave. And I went to work for the company called Catastrophic, who was in Searcy, Arkansas at the time. I thought I was moving to Arkansas, closer to home. Little did I know that D&V was headquartered in Houston, and the company they bought it was going to be moved to Houston. I didn't know that at the time. So anyway, I come to D&V. They specialize in advanced, as I said, acoustic emission and automated ultrasonics, materials engineering, replication, and then, really the foundation for fitness for service. So they wanted somebody that knew about the industry to help them build their land-based industry here in the U.S. And I was bodacious enough to think I could do all that. So I came to D&V and I was on a road trip. We did a lot of work for Monsanto, acoustic emission testing of fiberglass and other equipment. So I went to St. Louis, which is where Monsanto's HQ was, and I met Greg. We hit it off. We went to a Cardinals game one night, and we became friends almost right off the spot. And then he came to Houston to work with us in the late 80s, and we became friends. And actually, we built pretty much a powerhouse at Detnorsky Veritas. Lynn Cayley and Tim Munsterman and a lot of people that are still around in the industry. A lot of companies came from our work together when we were at D&V. We were there. I was there almost 9 years. It was a great place to work.
You mentioned acoustic emission testing. Were you doing the ND work? Were you supporting it from the engineering side? Talk about that.
Both. I remember one time Greg and I actually ran.
I'm laughing now.
Yeah, I am too. We did an AE test on ammonia tower down in Louisiana, and it was a cluster. I'll just leave it at that. But we did it. So we did a little of both, Brandon. I mean, fundamentally, I think what I did at DMV and really all through all the companies I've worked for is brought an understanding of the equipment, how it's operated, and the philosophy of the people in the plant, of what they want, what they need, even if they tell you or don't tell you. And at DNV, we brought an understanding of the equipment and married that with how to apply the technology to an acoustic AE or automated ultrasonics, how to detect and quantify defects. And then the next step is, what do you do with those defects? Does that sound familiar? I mean, here, 40 years later, we're doing the same thing. But fundamentally, I think, Brandon, if I have any value at all, it's in understanding, as I said, the equipment and the people who operate that equipment and what they need. If I have a value, that's probably it.
That's your superpower, relationship building and communication.
I think so. One thing I kind of want to hit on, when we were at DNV, my Andy Warhol moment happened there. We were using equipment from the Danish Welding Institute. It was one of the first automated ultrasonic systems. It was small. It was not much bigger than a laptop and some of the equipment that we use today. Anyway, I got invited to do a demonstration at NASA, at the Kennedy Space Center, after Challenger, which was in 1987, I believe, January of 87, February. So this would have been an 88-ish. Anyway, they saw the P-scan. We were at AS&T conference, and they saw the P-scan, and a gentleman named Jim Ye invited me to the Kennedy Space Center. So no, we were all busy at DNV. Everybody was on the road, except we had two young guns we had just hired from Hutchinson up in Minnesota, Mark Imslander and Lenny Pangrel. They were like 19 years old. So we went to the Kennedy Space Center. We set up to do a demonstration on a piece of flight hardware, the solid rocket booster aft skirt down at the bottom of the white solid rocket boosters, about 2-inch thick, 1.5-inch aluminum. So we set up to do a demonstration with a P-scan, scanning the weld to show Air Force and NASA people how it would look. And they were trying to improve or raise the level of the technology they used for inspection. So during the inspection, Mark comes up to me and says he's found a linear indication in this weld. Now, this weld was on an aft skirt that was going on to the space shuttle, Discovery, the next one. So I'm like, dude, no, you didn't. This is going into space. This is, go check it again. Anyway, so he went and checked it again. He went and checked it again. And sure enough, it was still there. So I went and told NASA what we saw. And they radiographed and brought in their crews that spent all night looking at it. And the next morning, we had a meeting with the vice president of United Space Boosters at Kennedy to go through what we had found. And you can imagine the environment, the political environment there after Challenger. Everybody was on pins and needles. So anyway, long story short, that was Friday. Monday morning, we had 4 crews that mobilized to the Kennedy Space Center. There was 33 aft skirts that we inspected over the next 6 months, year. We were on the cover of USA Today, Florida. I was on TV. We were asked to sit in the VIP section when Discovery launched the next time. So for a young kid that wanted to be an astronaut, that was as close as I was going to get, and it was pretty cool.
I remember that. That was pretty cool. We were all watching from inside of DNV. It was awesome.
It was, well, I still can speak of it fondly, and I can remember all the details, and that was a long time ago.
But it was the beginning of, obviously the automated UT was proving itself, because there were sometimes, right, that there'd be false positives and stuff like that would hurt the technology. But this P-scan and the automated UT thing started, I think, maybe bringing more reliability as long as we had better operators.
So was that the plan at DNV to build up, just gather as much talent and start? Because the 80s seemed like it was a really cool cowboy type time where a lot of new technology, a lot of new understanding was happening. Was that the plan, or did that just kind of happen organically?
Well, and Brandon, that's a very interesting question. Thinking back about it, when I left the refinery, we had shut down, 50 or 60 small refineries. We'd integrated some into others. We laid off 30-40% of our workforce, both hourly and salaried people. So the industry at the time in the mid 80s was hurting with the oil embargo,
The other thing that was happening at that time, growing up in St. Louis, this part was stark. It was the beginning of the Rust Belt. The EPA was coming in, all these laws were coming in, and especially around the St. Louis area in the Midwest and stuff, and I'm sure it was down here in Houston as well as other places, is a lot of plants started shutting down.
They did.
Meatpacking houses, foundries, refineries, chemical plants.
Yes. It changed, but Brandon, to your point, I think Dos Veritas was trying to get more into the U.S. market. They were an ocean boat-based group. The good thing about DNV, they invested in technology and people at the time. Yes, they were out to make money, and we did make money. So was it I think maybe at a high level it was planned, but the reality was it was to integrate advanced inspection and mechanical integrity technology into the industry, specifically land-based industry, which DNV was not working in at the time. Just because the U.S. is the largest market at that time in the world by far. I tell people, I love working there. Equity engineering folks started there. The RBI, risk-based inspection, was started there, working with Shell and ExxonMobil to develop the technology. DNV was working the approach overseas for shipping, but not really for land-based equipment. So we started working on that. And that's where the foundation, like I said, for fitness for service and RBI. So it was the foundation, not just for technology, but myself and Greg and our relationship. Most of those people we're still really good friends with, no matter where they work.
Throughout your career on the technical side, where was a lot of your focus at?
Well, at the refinery, it was being inspection and maintenance. I literally worked on every piece of equipment or had exposure, to inside of towers and cat crackers and plant reformers and crude units and heaters. And, I've helped light burners on heaters. I've helped put out fires. We talked about CPR, the fire team. We were changing relief valves on the top of the cat fractionator when a tornado came over. Lightning striking a tank that caught fire.
Hold on. You were on top of a cat cracker when a tornado came through?
We had just finished a cat turnaround. That would have probably been 83. And we brought the cat back up. And lo and behold, one of the relief valves, we had two big relief valves on top of the cat fractionator. It literally, it opened and broke, and we had to shut the unit back down. But we still had the crane up. So we were pulling the relief valve. It was a big one too, 12 inches, I forget, but it's big, off the top. And as we were doing that, a storm blew in or was blowing in, and we positioned the crane. We didn't lower the boom, I don't think. Maybe we did. Long story short, yes, we were pulling a relief valve. We were up there. The pipe fitters were changing out the relief valve when a tornado came over the refinery. And I spent the entire night in the refinery. Some of the night when the tornado came over, myself and one of the maintenance pipe fitter foremen hid under us a big old steel table in the pipe fab shop. But that was very exciting. I was there 2.5 days straight, no sleep.
Your definition of exciting is a little different than mine.
Yeah, well, I didn't choose that, Brandon. Just like I didn't choose, when we did CPR or being on the fire team. But technically, I crawled through cats and cyclones and fractionators and trays and, heaters. And I was covered in oil more than once. I got sprayed we had a sulfuric acid alky. And I remember walking into back in those days, we didn't wear Nomex. I walked into the plant. I had a down jacket on. And I walked in, and the refinery manager, we had just got the unit back up, but I was sprayed with sulfuric acid. Not bad, but my down jacket looked like a duck feather or goose feather, pillow. And there was feathers coming all through the office when I was walking. And the plant manager bought me a new North Face down jacket after that. But working in a refinery and with the equipment gave me a foundation technically. Now, when I went to stress, of course, stress and equity and back, I'll have a lot of really smart people, probably smarter than I am. But what a lot of them lacked, Brandon, was an understanding of how to apply the technology to solve a problem, how to bound the problem. Does that make sense?
Mm-hmm.
Technically, that's my superpower. At stress, when I took over the downstream practice, there was, they had masters and PhD guys that FEA and, and fraction mechanics, all of which I could probably do if I had to, but God Almighty, you might not want to look at the result. But the one thing they couldn't do, or they didn't understand what loads, what problem they were trying to solve, how to put the loads together, what was really going on with the equipment, both, not just mechanically, but as you know, everything we do in a plant is operator dependent. So how is the equipment run? What's the flow rates? What's the pH? What's going on inside, right? And that's what I was able to do pretty much wherever I've been, is help people understand the science, not the calculational science, but the application of technology to solve a problem. Does that make sense?
Yeah,
Mm-hmm.
a matchmaker.
So
yeah,
that's the technical part, really. And that hasn't changed in 40 years. Now, it's changing now. As you know, we've got a new game in town around artificial intelligence. And you and I have gotten to know each other, around that a lot. And I was asked to look at a project that we were working on here, applying AI to fixed equipment. And, the last 6 months, I would argue that it's going to change everything we do and how we do it. And I'm excited to learn about it. Honestly, I mean, if you could teach this old dog, some of that stuff, that's what's exciting me right now. I think back to my dad, who was a car guy, but, he was born in 36. So he got to see a lot of stuff that advances in technology after the war and assembly lines and, so on and so forth. But if you think about it, Greg and I have got to see everything from the space shuttle to computers to cell phones. I mean, we didn't have any of that starting off. We didn't do science with computers.
Yeah, we didn't have desktop. Well, we had black and white TV when I was a little kid. We got color in a couple years.
Yeah, I mean, Brandon's laughing his ass off, I know, but it's the truth. But we've come so far, and yet I think this AI wave, how we use that to improve not just our industry, but also to improve our lives.
AI is interesting, right? I kind of think about it like this. The advancements in NDE back in the 80s and the 90s allowed for us to make smarter engineering decisions, right?
Right.
Because we were
right.
able to better understand exactly what we have out there.
Yep.
So AI is now going to come in from an operational standpoint. What do you think it's going to help boost? Do you think it's going to help boost something new? Or what's the future there, do you think?
I don't know. But what I see is I think everything, to answer your question. Guys, do you know how to use AI? Do you know what it's used for? Do you know what it can be used for? The answer to all those questions is no. So we are here to build a foundation to learn and help each other get our heads around the technology, what it means to us, how we maybe can use. But it starts with learning about it first. And then we'll decide what we want to spend money on it. I had one of our friends say, well, Bobby, I don't know, our company, we need to know what the deliverables are before we want to spend any money. And I'm thinking, well, bud, you don't even know what it is or how to use it. I know that for a fact, because while I may not be a PhD in fracture mechanics, I'm not a dummy either, but we don't know.
Yeah.
I mean, I mean, there are certainly people that know more than we do, but that's why we're coming together to learn from others. Go ahead, Greg.
I think, Bobby, one of the big things we're going to get out of AI, I think we're going to get a lot of stuff. I think we're at the tip of the iceberg, quite frankly. But I think a lot of the stuff we're going to get out of AI is going to help us understand the uncertainties and the confidence we have in our predictions. It's going to help us take better advantage of data that's available to us and other things. It amazes me, quite frankly, when I hear the industry talk about AI, and you got companies like Microsoft starting up an old nuclear plant to help power AI stuff. It's like, my gosh, it's hard to fathom, all of the impact of AI. But I think it's a lot of promise. I think there's a tremendous amount of promise there. And it's like anything. I always said the internet is a parallel universe. You can use it for good. You can use it for evil.
And both
think it's true as AI.
That's right. And people do, they do use it for that. So we'll see. I mean, I am so excited.
You mentioned cokers. Your name's been associated with cokers for a long time. How did you get into the coker world?
That's a very interesting question. At the refinery where I worked, we did not have a coker. We made asphalt. I'd never want to go in another asphalt plant. They're nasty. Actually, another thing, sidebar, one of my best friends, I played softball. We started a softball team at the refinery. One of my best friends, he was an operator, walked under an asphalt vent just as we had gotten some water carry over into the tank, and it puked over asphalt all over him. And he went to the ER, and he had 3rd-degree burns over the top. I didn't mean to get off on a tangent, but it's true. And that affected me there for sure. When I left the refinery, when I went to DNV, one of the pieces of equipment that we were asked to look at was a coker in Corpus Christi. Anyway, long story short, we started working with applying strain gauges and thermocouples and doing acoustic emission, because cokers are crack machines.
What does that mean, that they're crack machines?
They're batch operated. They heat up from about ambient, maybe 150, 200 degrees to 850, 900 degrees every day. They cool down with steam or water. So
and they're huge, right, Bobby?
They're 30 feet, or well, they're 24 to 30 feet in diameter, carbon half moly, 1.25 chrome. They are designed as pressure vessels. They were not originally designed in a fatigue service. So long story short, the industry moved from a 24-hour cycle, which it ran for years, to 12, 16-hour cycles in the 90s. And what that did, that started accelerating fatigue damage at a much higher rate, especially on equipment that was 20, 30 years old. So they started having through-wall cracks, both in the shell courses, the shell 3, 4, and 5, also down to the skirt areas where the skirts are welded onto the cone. And then you add on the delta valve, the bottom unheading devices and the top unheading devices, and putting a side inlet on, you could run them faster. You had another thermal gradient with the coke coming in at 900 degrees into the cone, hitting perpendicular on the other side. Anyway, all of it just basically accelerated cracking all around the drum. We built an entire business around monitoring that, measuring the loads with strain gauges and thermocouples, finite element analysis. And my passion is understanding the reliability and where the cracks are going to happen, how long they're going to happen, how many cycles, but also in tying it into operationally. Having worked with operations daily, I know for a fact, I knew even then, even though I wasn't a process engineer, that the way drums are operated, switch and quench procedures specifically, can have a huge impact on how fast they damage and crack. And operators, basically, we're raised in a refinery, have operations and process and maintenance and engineering. And operations process, we run it. Maintenance and engineering, you fix it. And don't give us a hard time if we break it. But back to cokers, we started working on cokers in the late 80s, and it has carried through my entire career. We did a lot. Stress engineering had a wonderful health. They did a lot of monitoring, so they had really good monitoring equipment, and we were able to put it on. And then when I got to Becht, we took the next jump, and we transitioned from wired monitoring to wireless monitoring. And now they're actually installing strain gauges and thermocouples off-rope access to save hundreds of thousands of dollars in scaffolding. But fundamentally, the biggest thing we've done is tying how you operate a piece of equipment, what it does to the equipment, and then making financial decisions and operational decisions, tying equipment response to the way it's operated. And that's something I've worked on for 30 plus years. And I never had a coker at the refinery, but I've been on a whole bunch of them, mostly North America.
Hey, Bobby, wasn't there some other good information that came out from all of that work too about how to design coke drums?
There was, Greg. We basically took what we learned from the way they were cracking, and we redesigned them. They were designed originally like a storage tank where they had thicker plates at the bottom. They transitioned to thinner plates moving up. We transitioned to the same wall thickness. We did a lot of work on metallurgy. We did a lot of work on grinding weld crowns smooth to reduce stress risers. But honestly, Greg, the reality was what we could do to improve the design was minuscule versus the process. They could tear up a bowling ball.
Yep.
Regardless. So what the biggest thing we had to do, and I worked on, is to try and convince the tech services manager and the coker process leads that we're not trying to tell you to slow down how you do cycles, but we're trying to help you understand that if you do that, one or two 10 cycles in a year can do 10, 20% of the damage on a drum. And if you can just improve those 10, 20 cycles, you can do a lot of good for your drums. On the reverse side, if you run them hard and you make $100 million in profits, then you just need to plan on replacing your coker in 5 years or your drums in 5 years or 10. But make that, at least you understand cause and effect. And that's really the whole input.
Something I've always wondered, were there any catastrophic failures of coke drums that caused fatalities?
There have been 3 or 4. mostly due to fires that were
Right.
caused. Luckily,
I mean, from the Coke drum itself failing, and not a line going to the Coke
well,
drum.
yeah, not as many as you would think. I mean, I've been involved with 2 Coke drums that the bottom skirt to cone attachment or cone to shell attachment, or skirt to shell attachment weld, unzipped 360, not pressure boundary, and then the drum actually set down inside the skirt a few inches, up to 6 inches in one case.
That's scary.
Yeah, well, it was. Luckily, those happened not during the fill when you had 900-degree oil in it. That's the key. I've seen when the side inlets have caused through-wall cracks. Luckily, Greg, we've not had a lot, but we have had some. I mean, there's 3 or 4 that have happened where the fire started. They've unheaded live drums operationally, and it flashed. Talked about some of the piping, the overhead piping or the feed piping. Because it's fatigue, all of the associated piping to the drums also have to be inspected. And that's something, when we transitioned from 24-hour cycles to 12-hour cycles, nobody understood the complete impact on the unit. So it just took us a while to get a handle on that. But, with RefCon and Coking.com, I've been involved with that since 2002 or 3. So it goes back a long way. Yeah. The reality is we've gotten better, but people are just now putting it into their DCS and making optimization changes, or really understanding but it's taken 30 years. We don't move at light speed in our industry.
No, we don't.
So you said they're putting in the new optimized quenching and reheating process, getting that into the DCS and having that programmed up to the proper timing. You said 12-hour and 24-hour. That's up and down, or that's one way?
Well, understanding that is kind of critical. You have 2 drums. When you're heating one drum, the other drum is cold, and you have one inlet that feeds both drums. So you got a switch valve in the middle. When you're heating one drum, the other drum is you're unheading and getting the coke out. And then when that's done, you button it back up and the other drum fills up, and then you switch feed going into the other drum. And that whole process, it's really looking at it, how it fills. But the entire cycle, is about 24 hours per drum, but it's actually, you're only in the drum for 12 hours, but from switch in to switch back in is about 24 hours, but filling a drum is we call that a 12-hour cycle. It's when you put oil in, and then the time you put the steam in to quench the drum. The key there is it's batch operated, whereas the rest of the refinery is continuous, right? And it wasn't designed like that. We've made progress on the designs, but right now the biggest progress is being made on the operational optimization side, combining it with reliability and planning for maintenance and repairs. So you're not stuck. I mean, we still get surprised by through-wall crack, but not everybody is monitoring their drums like they should be, in my opinion. Yes, it costs money, but an unplanned outage is $500,000 to $1 million a day on a coker, depending on margins. So if you can prevent unplanned outings, if you can plan for maintenance versus, unplanned maintenance is in a turnaround is 3 to 4, 5 times what it is when you plan for something. But that's still peanuts versus how much throughput you're going to lose.
Yep.
So if you had, the Right Stuff refinery and you were in charge of designing and operating the cokers, what would be, maybe just from a high level, what would be the key things that you would do to optimize all of your reliability?
We're still siloed inside a refinery by process operations, maintenance, inspection, or engineering. So one of the things, and some companies are doing this better than others, is that team would work together. They would be responsible for the entire throughput and the entire reliability of that unit. Now, again, some people do that, but there's also they got variations, and they would work. When they talk about switching, right now we're big on running opportunity crudes, and different feedstocks create different coke products, create different impact on the drums. So understanding what crude you run or feedstocks you run and what impacts that has, as you're making those decisions process-wise, a maintenance or reliability engineer should be in part of that team. So when you make that change, they understand what's coming and what to get ready for. It sounds very simple to do, but working as a team rather than working in silos better. But we've got people now that are working towards that end goal. But if the Right Stuff Refinery, I like that. We would work together for the integrity and the throughput financially, as well as the equipment, and make decisions. If you have a process engineer that tells a maintenance engineer that I can make $100 million in 6 months, instead of repairing the drum every 5 years, you're going to repair it every 3 years. But yet of that $100 million, you're going to stick $200,000 in your bank account. What is the maintenance engineer going to say? He's going to say, run the heck out of it and I'll have it ready to fix. And a lot of people work hard to do that, but they don't all succeed. I remember going to a refinery on the West Coast, and we were implementing this strategy there. The operator that ran the drill stem and responsible, they had 2 or 3. Their maintenance engineer, the reliability engineer, ops engineer, the process engineer that was responsible for the coker, they all had less than 4 years experience, and they had never met each other. So building those bridges, again, Brandon, people, intangible, that is arguably one of the things that I try and focus on. Leadership, while they try to do it, sometimes they don't know how to get people to work together and help each other.
How dependent is it, Bobby, on certain key leaders in the coker unit? Like, for instance, can you institutionalize these best practices? Are they highly dependent on when that person leaves?
Greg, you can absolutely institutionalize it. You can create best practices. For instance, before the advent of all the instrumentation and the controls that we have today, now we have automated controls, what you're talking about, that, that really controls how coker's operated. Now, when you have an upset or something happens, then you have the ability to take it off automated control and go manually. I remember one project we worked on in Illinois, we found that 80% of the fatigue damage happened on evening and night shift. When we drilled down, we were working with tech services out of corporate, as well as the coker superintendent process lead. And when we showed him what was going on and what we saw when it was happening, and it was in the switch and quench procedure, they were switching into a drum. They didn't preheat it, and they were filling it way too fast. And what was happening, they were taking it off automated and go to manual, not because of an upset, just because they were cowboying it. And I remember once we got the operations superintendent to see what was happening, he goes, well, I'll fix that.
Yippee-ki-yo-ki-yay.
Exactly. So to your point, we've come a long way. It can be institutionalized or regimented, understanding what best practice looks like. There will always be some upsets, but the better you educate, not just the process people, but the guys and gals running the unit, it can't just be at the engineer level.
Yep.
It's got to be down to where the people run the equipment. Because if they're not on board and they don't understand why, you can't just tell them to do it.
Yep.
They have to understand why.
Yeah, agreed.
When I would go to a refinery, I was always blessed to work around really sharp mechanical engineers. But my superpower, if you will, is trying to educate and communicate that to operations and process folks so that they would understand.
That's priceless, man. I remember, I don't know if it was the same refinery in Illinois, but I remember we were implementing RBI in there, and one of the senior inspectors who was part of the core RBI team got so jazzed about what he learned about heaters and what we were talking about heaters, that he took it upon himself to put together a small curriculum and a schedule, and he would go out to every unit with a heater, whether it had to be on the midnight shift, the afternoon shift, or the day shift, because he wanted to educate the operators so that they understand when they do this to the heater and they do that to the heater, here's the trade-offs, here's
That's
what's
right.
happening. And that's probably similar to what you're
Well, it's exactly the same. And then the other thing too, they're the ones in the unit all the time. Okay. Engineers, if something bad happens, it's not going to be us that gets hurt, burned, or killed usually. It's going to be them.
Yep.
So the more we can do to educate them, that's why what I do, I don't do it as much anymore because I'm not in the plants as much as I used to be. But my point is, to your point, our points, is it is about education and them understanding why to do something, why not to do something. And it can't just be, I run it, you fix it, because it might fail at 3 a.m. when you're out making your rounds and it's your rear end. So that's the point we want to try and get across.
No unanticipated downtime, and certainly not hurting anyone.
Well, we try.
Right.
But what we do is dangerous. That's
Yeah.
something else. We've gotten so much better than it used to be. We get lulled into a false sense of security a lot, but it's just like driving, just like they say, don't text and drive. And I still do things I probably shouldn't, but man, one mistake and it's all over.
That's right.
I've been sitting here thinking, Bobby, it sounds like your time at the plant was really influential on kind of your overall career and your overall path. Are there any other major experiences, events, something out there that was really influential on kind of getting you to where you are now?
It's all cumulative. Some play a big role, some play a small role. A lot of it you don't realize when you're in the moment. The thing I try to tell my kids is everything that you do, good or bad, will define or determine your path. The question is, how do you use it? And again, the worst things that happen, bad things that happen sometimes affect you more. I don't know, Brandon, I believe everything happens for a reason, certainly my time at the plant, but everywhere I've been has led to another opportunity that has been better for me. So it's how you look at it. Change, I used to hate change, and now I embrace change because it's part of life. And when people get hit with adversity, it goes back to what we talked about early on. It's how you deal with it. And when you're in the middle of it, you don't always see that. I mean, all you see is the struggle. You don't see who's necessarily there standing beside you to help you with that struggle. But for me, each one of those life changes has been an opportunity to grow. As I said earlier, I don't know that I would have changed a lot because I'm blessed.
You mentioned a couple times now that you've got the skill set to be able to kind of operate across the entire ladder from the line workers from back in the day all the way up to VP. What do you think it is that allows you to do that? What skill did you pick up, or what has it been that you think that piece for you where you can do that?
Some of it can be learned, but I think for me, and you guys know me a little bit, my mom's shaped my personality, my family a lot. I mean, I've always been outgoing. I've always been relational, even in high school and college. And I think working with other people just kind of brought that out. Also, I have a servant's heart. I care about people, even though we are a pain in the rear end. Myself, I have no exception. But for the most part, I think some of it's God-given, and then some of it is intentional, if that makes any sense. I think as I've grown, I dare say mature. I don't know that I use that word for myself a lot, but understanding what your gifts are and how to use them. And I think my relationship skills with people, I genuinely care, so it's not fake. And most of the time that comes out. I also have a little fire, so sometimes it comes out with a sword, but most of the time it comes out that I genuinely care about people.
Now, I can attest to that, Bobby. I can attest to that, bro.
You mentioned your dad a few times. Was he an engineer? He was plant manager. Was he an engineer background?
He has degrees in industrial management, but effectively an engineer. He was, my grandparents, they lived through the Depression, which my dad, was, he was born in 1936. So that's a whole foundation for work ethic. And he was very stoic. I got my personality from my mom. And what I mean by that, he worked hard. He didn't say a lot. He was one of those, I've got a lot of friends whose parents who grew up in that vintage They lived through World War II, and it just affected how they viewed life, and the fact he didn't grow up with a lot. So he worked his rear end off, and I think I started working when I was 13, helping my grandpa bale hay, and then I always worked, and I actually love working. I don't look at what I do as work. For me, it's almost a mission. It's my purpose. I want to help people that want my help to either, mentor their leadership or their engineers or even a business action plan. That's what I love to do. I've had a company ask me recently about some Coker stuff, and they're just way off base with where they're going, but I think that's the benefit of where I can help people, not just leadership, but if they want it. I try to help people understand their value as well as the value we offer, to a client. But at the end of the day, it's people. It's the name on the back of the jersey that matters. It's not the name on the helmet. After I left Stress, I had one of my he actually worked for me, and we got in this conversation, and I guess he said, and it was a really nice compliment. I guess he said, well, you showed him that it wasn't the company name that mattered. It was the name on the back of the jersey that mattered. And that was probably one of the biggest compliments I've ever gotten.
It's a nice compliment to get, for sure.
It was.
Yeah.
It was.
You mentioned building teams and hiring. What's the number one trait that you look for when you're talking with folks?
That's a really good question. Tosco at the refinery, they also, in the good times, they sent us to a week-long, actually we did 2 weeks, on hiring and what to look for in engineers. They put us up in the Ritz-Carlton in Los Angeles. So to see Redneck Bobby from Arkansas at the Ritz-Carlton at his young age, that's a whole nother story for another time. So learning about what to look for in people, how to interview people, for me, it's looking for obviously technical ability, okay? Understanding, can they do the science, number one. But what I really focus on, Brandon, is who they are as people, what's on the inside. We would have a team of people interview, and then they know how to do fractional mechanics or FEA, whatever we were hiring them for. But what I would do, I would work to try and get to know them on the inside. Greg mentioned resilience, perseverance, ability to communicate, trustworthiness. I mean, it's hard to take a checklist and, yes, you're trustworthy, but we would ask questions, or I would ask questions to try and find out how they handle certain adversity or certain issues to make sure they weren't going to give up. Mm-hmm. So, Brandon, to your point, trying to understand what's on the inside, there's a lot of ways to solve an engineering problem. People are always involved, whether it's getting information, getting good information, asking the right questions, being able to get along with your peers, being able to get along with your clients, not being arrogant. Engineers love to prove how smart we are, but that doesn't always come across very well if you're a consultant, right? So, and dealing with consultants that work for me that are asses to our clients, that's just not going to work. Commitment to service, treating people like you want to be treated. Those are intangibles that I always tried to look for. I mean, I had a checklist of things that I, kind of went by, but fundamentally that was it. We set up a protocol for mentoring that if you were coming to work for us, you would meet with the people you were going to be working with, and we'd have a lunch, and you would present in front of all of them because you were coming into a team. And if one of our team members did not get along or had a concern about you coming in, it had to be resolved before we hired you. It was not just, I want you here. I mean, sometimes, yeah, we had people that we really wanted, but it was a team decision.
Nice.
Makes sense. Yeah.
Building on people in your 45-year career.
Thank you, Brandon, for reminding me.
Yeah, no problem. Yeah. Who would you say have been obviously it seems like it's pretty evident that your parents were very influential on you. It probably sounds like Joe as well. Anybody else throughout your career that have really helped shape your views, that have helped you along the way?
Well, again, it all starts, you mentioned mom and dad, my grandparents, but in the industry, everywhere I've been, there's always 3 or 4 people at the refinery, Paul Creel, Milton Pyron, Ted Day, Robert Love. I can still remember their names. That was in the late 80s. D&V, Greg and Lynn and Mike Wexler and Tim Munsterman and Keith Brown. At ERA, I worked for Dr. Brian Kane and then Chris Perks, and then some of the guys I still hang out with. Everywhere I've been blessed to really become really good friends with some of the smartest people I've ever worked with. At D&V, Odd Tour Sagarood, I can still remember there were some other guys, and then at ERA, John Breer and Dr. Kane, and then at Stress, there was Richard Boswell and Claudio and Chris Alexander and Julian Bedoya. And again, everywhere I've been, and it backed, Dave DeWeese and the Backs, the family. Joe had a lot of impact, as you've heard. But everywhere I've gone, I've been blessed to make really good friends, and friends that have stayed, like Greg, that even though we've competed together against each other for off and on for 30 years, we're still friends. And at the end of the day,
we've collaborated for 30 years.
Well, we did. We've helped build other people's companies, and
we've been able to overcome the competitive envy or any of that kind of crap to still be friends.
Well, and look what
help
we're doing
one another
now.
Yeah.
Nice. Good. Greg, anything else interesting?
No. Well, there's a few things, but we'll leave those in the closet. Those skeletons. No, just well, not kidding, but I'm kidding. Bobby, who was the one that was up at the top of that crane basket when that AE test was going on? Was that you or me that got wet up there?
That was you.
That's right. You were on the bottom with the operator.
Yeah, I was on the ground.
Yeah, that was an experience. I was going to say that was an experience.
Well, when you mentioned crane basket, I was actually on the top of a crane basket, at the top of a flare, doing a flare inspection, 300 feet off the ground. And if you've never been in a crane basket 300 feet off the ground, it's a little, if you say anxiety, that's not even. And then one of my good friends, also in maintenance, he had the crane operator drop the crane basket about 30 feet free fall.
Oh, geez.
Yeah. And then he didn't let me down for a little bit till it cooled off, but I still got even with him. But back in those days, he's lucky I didn't kick his rear end.
This stuff was all pre-PSM, I want to say.
Oh, yeah. No, you get fired for stuff like that today. But we did a lot of stuff. The fact that I'm still alive, God's not done with me. I had a 36-inch monkey wrench fall off the top of the cat structure that hit a handrail right beside me, severed the handrail. That was literally, and if it had gone, it went to the right. If it had gone to the left, it would have killed me. The tornado, the alky unit, the CPR, anyway, and then some other stupid things I've done. But
it sounds like you're the reason OSHA was invented.
I probably was. I was. Well, now granted, I didn't do all of those things. Some of those happened to me. But the fact that, that we don't have more people killed than what we do is probably just a gift from God.
Agreed. Even when these big things happen, it's amazing sometimes. They could have been so much worse.
It really is. I mean, we have things happen all the time like that.
How do you want to wrap this up and bring it in, Brandon?
Bobby, I think this has been awesome. I mean, I've gotten to know you a little bit over the last few months, but to have the opportunity to sit down and kind of hear even more about where you come from and what's helped shape you and who you are. And it's been really a nice pleasure here. So I appreciate you taking the time. I appreciate it.
I appreciate it. Appreciate you asking. I've enjoyed it.
Thank you for listening to Upon Further Inspection, a mechanical integrity podcast. This episode was co-created by Inspectioneering and Core Solutions. Our producers are Nick Schmoyer, Jocelyn Christie, and Jeremiah Wu. This podcast is for informational purposes only and does not constitute legal or professional advice. Listeners should seek their own qualified advisors for guidance. If you enjoyed this episode, please join us next time wherever you listen to your podcast. Until then, stay safe and stay informed.